Okay, so anybody want to shout out a 40 on that one? 0.6. Was it just 0.6 or more? 0.64. 28. 25. Does anybody have that one for decimal? 423. Okay. Anything going on with these numbers? They're the same. Like this is 0.5, and then this is 0.64. Okay. So, can you see anything that's common with something? So if I look at this and this, they were the same, so what's going on with the angles? This and this were the same. What's going on with the angle relationship? Anybody have a relationship or connection with the angles?
You add them together, they make 180.
These two make 180? Okay, do these? Yep. What about these? Yep. Okay, so here's the rule. The sine of any angle should be the same as the sine of its supplementary angle. Do you want to test it? So let's go, if I ever did the sine of 20 degrees, the sine of 20 degrees should be the same number as the sine of 160. So I'm just looking on my calculator. Is this true, or is Mrs. Falk just making up stuff? Does it work? It does. Okay, so now how do we take this concept and work backwards from it? Okay, so if I give you the trig value, what is the angle? How do you get an angle again? Inverse. Can you inverse that? Did you get 80 on your calculator? 79.99, 80 degrees. But that's not the answer. That's half of your answer. Or what else could have worked? 100. Do you think your calculator could do that for you? Can your calculator do, hey, the angle could be this or this? No. Do you want to try? If I had done the sine of 100, will it have worked out for me? 0.9848? Yeah. Okay. Can you tell me this answer then? You have to be smarter than your calculator. Your calculator won't actually give you the full answer. So there's actually two that will work. So inverse sine, your calculator should have said, did it say 25? But you should also know that 155 should work as well, right? Nope. What am I doing? This is 55. Sorry, I saw a few faces and I'm like, what did I do wrong? And then I looked at my calculator here. 125. 55? Did I do that right now? Okay. So, do you understand these words? Have you ever heard this word, acute? Your calculator will always tell you the acute one, the small one. And then the other one is obtuse. Okay, so I'm going to go back to this concept here. So, do you see that I have two triangles? So I'm going to color code this here. Let's see if I can do a highlighter. Maybe. Okay, do you see that yellow is triangle number 1? Okay, it is the obtuse. Right, that's an obtuse triangle. Okay, and then there's another version I could have done. So that's the other triangle that could have formed. Do you see it? And then I'll call that one the acute one. Okay, so let's see if we can do it. You ready? It's gonna get crazy. There we go. So this is angle A, 35 degrees. Side B is adjacent to A. And then 7 is opposite. So did you see that this was the case where I swung the shorter side and it made two triangles? Okay, so I'm just going to highlight for you so you can hopefully see it. So here are my two triangles. This one is 9, 7, and the third side. 9, 7, and what? And my other triangle is 9, 7, and what? You see that? How I'm going 9, 7, and what? Because I get people who solve for this, and that triangle is 7, 7, and what? I don't want that triangle. I want 9, 7, and the third side. Okay, here we go. So we're going to go pair, sine law, 7 and 35, sine law pair, nine and sine of angle B. Okay, times, divide, inverse. Okay, so this was our ambiguous situation, our SSA, so I need an angle or another angle. You can have two options for angles. So here's the rule we just did. So did you put 132.5 as the option your calculator can't tell you? Okay, so in the drawing, I'm going to find the angle across from B. So this is across from B, and in the pink, that one's across from B. Does it make sense which one is the acute one, which one is the obtuse one? Do you see it visually? So farther away is smaller, closer is bigger. So those are the two options across from B. Okay, I'm going to draw the triangle separate, just so if you're having a trouble seeing it. Okay, so this is my yellow triangle right now. Can you get the top angle in my yellow triangle now?
Yep.
Is anybody 12.5 degrees?
Yep.
So if you can leave it on your own diagram, or if you are having trouble seeing it, you can separate the triangles now. Okay, so I'm going to solve for side, and I'm going to call it C. So I'm going to go 7 and 35 are across from each other. Side C is now across from a 12.5 angle. Okay, so this is a bunch of sine law stuff that you know. It's just now it's like got a lot going on with it. Okay, times and divide. .64 is what I got. Okay, now we're going to go into the pink triangle. So this is the part that's kind of tricky where some people get a little bit messed up. Okay, the 12.5 is in this triangle, but really I want to know this whole thing. So if I look at, it's separated a 9, 7, I have a 35 and a 47.5. Right, that's the pink triangle if I drew it separated now. So what's the whole entire top angle then? Okay, so 97.5 degrees. So sine law, I'm going to go 7 with the 35 angle. And this time I'm going to put the unknown across 97.5. Okay, same idea, times divide.